Peace, peace. Come on, man. It says video starting. Like, so start. Yeah, man, it's good. You're always trying to screen some shit. Peace, peace, peace. Welcome back to the Universal Temple. For the Sun, Planet, Moon, and Stars, I'll be your host, Lord Messiah. And today we going in on gravity versus repulsion. Which one is it? So, it's been a lot of talk lately about, the whole theory of gravity, you know what I mean? And the reason why I say theory of gravity is because, what they're saying gravity is, due to my understanding and due to the study that I'm about to break down, gravity is not really what they saying it is. You know what I'm saying? So check it out, right? Or rather, I say, whatever they're saying this is not really applying how they say it is. So y'all read that real fast. I'll be right back. All right. So it says gravity. It says gravity, the force that attracts a body toward the center of the earth, or toward or toward any other physical body having mass. Really? So then it says extreme or seriousness. You know what I mean? Like, the gravity of the situation, is really serious. So anyway, like, holds a lot of weight, so to speak. You know what I'm saying? Like, as they say. So now, it says the force body toward the center of the earth, or toward any other physical body having mass. So if that's the case, uh, that means that physical things in the universe that have mass, they're supposed to attract to each other due to gravity. So why don't everybody just like bump together or like all cling together and like, oh, everywhere you go, you'll just be gravitating toward people and bumping into them because of gravity, which is supposed to be the force that attracts a body toward the center of the earth or toward any other physical body having mass. So if that's the case, then like I said, so why don't the planets collide or clash together? Why don't the sun and the moon attract together and boom, clash together because of gravity? Like, you know what I'm saying? Like that doesn't even really make sense, man. You know what I mean? So like they say like, okay, well, according to Newton's law or whatever, they say, oh, what comes up must come down and all of that, right? Remember that? He taught you in school and all that? What comes up must come down, so they say, right? So I posed the question of helium. You know what I'm saying? And what about helium? You know what I'm saying? Like they say helium, not even they say. I'm saying that how they say that nothing can define gravity. You know what I mean? So I say, okay, so what about helium? Helium and heat rise and defy gravity all day. You know what I mean? So it's like, what is it really? You know what I mean? So I'm gonna show y'all this right. Let me just go real fast. Oh yeah, I asked that question earlier. Tell us what you promised your nation. Only one person answered. All right, so yeah, I said right here. So I say they say nothing defies gravity. Heat and helium rises and defies gravity all day. So I said gravity is a myth. Prove me wrong. You know what I'm saying? Now there was a couple of people that said a couple of things. You know what I'm saying? Let's read some of the comments here. You know what I'm saying? Okay, never thought about that. You know what I mean? I said, I think very deeply. You sound like Lord Jamar. I said, no, I sound like Lord Messiah. All right. All right, so this brother said, here's a simple one. Satellites, let me read this off. Let me drop these paragraphs on me.
Like, here's a simple one. Satellites and all other celestial bodies. We know for a 100% fact that they are all rotating at fixed positions and rotating on an elliptical. Using Newton's law of gravitation, we then can predict and consider what will be the gravitational pull will be on an object and accurately send it into space at no limit of time. This is how we have GPS. We can also use Newton's law to predict the celestial position of planets with a high degree of accuracy. If there is no gravity, what is the force in which pulls objects down towards the center and keeps objects like satellites in orbit? Like.
Right. Now, see, that's what I'm saying. So, if gravity is the force that pulls objects toward the center of the planet, why don't it pull that orbit, that satellite, toward the center of the planet? You see what I'm saying? Like, what, it only pulls certain objects toward the center of the planet, or does it pull all objects? Because according to the definition before, it says any other object, you know what I'm saying, towards something that has mass. So basically, objects that have mass, they're supposed to attract toward each other. So I have mass, another person has mass. Why don't we attract toward each other? Come on. The Pluto has mass, Jupiter has mass. Why don't Pluto and Jupiter attract toward each other? How come they're in their fixed formations? See, and even that satellite that they say is supposed to be orbiting the Earth or whatever. How come that satellite is in its fixed formation? Why don't that satellite with another satellite or attract to the center of the Earth? You know what I mean? Like, that doesn't make sense. So now, another person. Okay, so I said another person said the original people hair defies gravity. That was peace. Because it's the Earth's source covering your body 3/4. You know what I'm saying? Like, yeah, man. You know what I mean? Your hair grows like a tree toward the sun for energy. It's gonna grow toward the window because the light is growing toward the light. You know what I mean? And your hair is the same way. So another brother says, heat and helium do not defy gravity. Simple Earth's gravitational pull isn't quick enough to affect those specific elements as efficiently. Earth's gravity does pull light either, but I'm sure you know what black holes. I'm sure you know black holes exist. So he says heat and helium do not defy gravity. He says Earth's gravitational pull isn't adequate enough to affect those. All right, so now this is why I go into the science of density, gravity, or density. Before I even get into repulsion, I'm gonna talk about density. You know what I'm saying? And density is simply the volume of mass of an object or whatever. So density basically equals mass. So they saying that, like, there's a force that pulls things toward the center of the earth. So like if I held a rock and I just like let go of the rock, because of density, it's gonna fall toward the earth because of its weight, not because of gravity. See what I'm saying? Because of its mass. Now, if I had you know, like on a kid's birthday, they holding a hot air balloon, they playing with the air balloon or whatever, and they mess around and they let go of the balloon. They be like, ah, mommy, my balloon went up in the air, right? And the kids start crying because he let go of the balloon. Now, because that balloon has what's inside of it called helium. And helium, now, like he was semi right in his statement when he says he said he put it as the Earth's gravitational pull isn't strong enough to pull those elements down, to pull helium down or keep it pulled toward the center of the Earth. But wait, that wouldn't make sense, because okay, so are you saying that heavier objects are able to be pulled toward the Earth, but lighter objects aren't? You know what I'm saying? Or the force of gravity is only strong enough to pull elements that are maybe solid and not gaseous. You know what I mean? See? So that wouldn't really make sense, because if anything, so-called gravity would be like an invisible force. And we know that something that's invisible is not necessarily not physical. It would be more etheric or ethereal. You know what I mean? As in like something being a principle of the mind, a state of mind, because we know the whole universe is mental, or rather I say elemental, El meaning God, Ment meaning mind, and Al meaning pertaining to. So the universe being elemental, meaning the whole universe is pertaining to the mind of God, of El. You know what I mean? So it's elemental, and we know elements are all the natural, particles and things that make up the physical structure of nature. And that's like air, water, fire, the basic elements we know, like air, earth, water, fire, air, sound, light, and thought. See, we talk about 4 elements, but you forget about, it's really 7 elements. You got sound, light, and thought. We know sound is vibration, and through vibration that can restructure molecules. You know what I'm saying? So and light travels, you know what I'm saying, from the sun. Light is a electron that has an electrical charge. And thought or ether is the nano world of your, what they call, we're going to get into what's called magneto sense or something like that. Magneto sense or something like that. You know what I'm saying? Like, you remember in the movie in the cartoon, the dude, Magneto. He has like, his mind is like a magnet because his mind is so strong, and when he thinks, he attracts things to him. The reason why people attract to each other is because of magnetism of the mind, because of their thoughts is why we attract. Not because we're physically, we just mass and we attract. Because if that's the case, not to be funny, but I am being funny, the next time I see a woman that got a big booty, she got a lot of mass, and I just happen to walk past her, if my hand just happens to move toward her big massive butts and it slides across her butt, I'm gonna blame that on gravity. If she get mad at me, I'm gonna be like, yo, it was gravity. Yo, you know what I'm saying? That was gravity. Like, look, the law of gravity. If I'm law of gravity, like, I'm calling police, you go to jail. Okay, well, y'all, the law of gravity states that two mass. The law of gravity states that mass, two objects. Come on now, really? Like, according to that's gravity, right? That's supposed to be gravity, right? So anyway, you know what I'm saying? But that's crazy, right? So, but in all sense though, in reality, the science is that, like, yeah, like I said, if gravity is not strong enough to pull down these lighter elements, but it pulls down heavier elements, then that's not really what you call gravity, because like I said, um, uh, it's really density. So really, what keeps us formation, like, or walk planted on the earth, you know what I'm saying, staying firm on the earth, and we're not like floating around the air. It's not because of gravity, it's because of our density. You know what I'm saying? Because of our density. You know what I mean? It's just like, for example, let's say if the wind, a windstorm came, right? The wind started blowing real hard, right? Now, like, say 300, 400 pounds, who has a lot of density, a lot of mass, that person will be more firmly rooted on the ground because of his density, as opposed to a person that weighs like 9, and then the wind start blowing, and whoa shit, they literally start blowing in the air. They get blown away, or something like a tornado comes or something like that. Big, hold his mass and hold his firm stance on the ground. But the skinny person will get blown away in the wind. You see what I'm saying? So now, is that gravity? Now let's say, now this is the thing, right? Gravity is supposed to be so strong. So you mean to tell me that now the force of wind is stronger than the force of gravity? You know what I mean? Like, come on now. Like, if wind could blow a person away, and then the heavier person stands strong, is that, well, gravity was more in his favor? See, and that's why I say, so then if that's the case, then gravity would be more in the favor. If gravity exists, then gravity would be more in the favor of the heavier, more dense, you know, objects, and the lighter, less dense objects would be less affected by gravity. So, like I said, when a windstorm comes, the lighter person gets blown away, the heavier person can stand. So I use the analogy of heat and helium. I said heat and helium rise. He said heat and helium does not defy gravity, because, you know, that, and then he started talking about you know, black holes and all of that too. Now, that's that's a whole nother science, and I'll get into another time. You know what I'm saying? But simply, black, when the star implodes, it collapses on itself, and kind of like, you know how you got like a reversible jacket. You turn the jacket around, it's a different color on the other side. You know what I'm saying? It's kind of like a star invert. So now, like, when a star is regularly like shining outwardly and giving out light, you know, outside of itself, when it not explodes but implodes, its properties kind of reverse or collapse, like an inner collapsing on itself, and then it kind of like reverse. And now, instead of shining light outwardly, it's now becomes like a vacuum and starts sucking all of the light, or the elements that imploded. It starts like sucking it like inwardly, and creating like what's called like a vacuum, like a vacuum type force, what they call a black hole. Now, the reason for that sucking back in of all the elements that imploded is to try to gather back all the material so that it can now explode again. So stars never die, they actually just regenerate. You know what I'm saying? Just like you regenerate brain cells, you regenerate sperm cells, stars regenerate themselves. Stars don't die. If they do explode, if they do implode, they reverse their properties, create that vacuum, what they call a black hole, and create themselves again. And also, symbolically, if we understand, in the universe, the wombiverse, the universe is symbolic to the woman's womb, the nightness, the blackness. So that black star, I mean, that black hole that creates that vacuum, bringing in all that energy into its center again to create again, is very symbolic of the black womb of the mother, in which when a man plants a seed in a woman, she germinates that baby through what they call the triple stages of darkness, or three months, 3 months. Those are triple stages of darkness. Those are the 3 trimesters, y'all. You know what I mean? That's how I break that down. But anyway, so, you know, and then the baby is born. You know what I'm saying? As we say, the baby symbolic to the star. The star is born out of the black womb of the black woman, which is the black Mother Earth. So Black Mother Nature, or the universe, which was founded in darkness, you know what I'm saying, and as before the light was brought forth. You know what I'm saying? Um, Shows and proves that very same science. You know what I'm saying? As above, so below. We are the universe. You know what I mean? So yeah. So all right. So let me go a little bit through more of these comments, and then I'm gonna get back into the build of what I was saying. So oh, okay. So now I said this here. I said thank you for your response. Allow me to elaborate. What is what is actually density is mistaken for what they call gravity. Thus, in correct perspective of what you said, less dense elements like heat and helium are not pulled or magnetized back to the earth because they are the opposite electrical charge uh, of the than the elements. I meant to say than the elements in the atmosphere, and I'm gonna get into that in a minute. I'll call you if you want to build about that because, like I said, it's too much to type. Like you hear all the stuff I'm saying and how I'm breaking down. It's like too much to type, man. Like you gotta know science and all that shit, and like like I'm it's too much to type. So anyway, I haven't, and I told him I got a video coming soon, so I'm gonna break it down. So it says I haven't heard this one. I haven't heard it said that nothing defies gravity. Who said that? Well, you never heard that before. A lot of people say that, man. Nothing defies that. You know what I mean? Nothing defies gravity and all that. You know what I'm saying? You heard that before. I've heard that before plenty of times. So anyway, actually, I think Sam Friedman said, Friedman said, actually, I think it's all about word choice. Although it's a weak force, gravity is everywhere. While you may defy gravity, airplanes, rockets, balloons, etc., gravity is still in operation. Okay, so like I said, see, so that's what I'm trying to say, see? So now he said just because, you could defy gravity doesn't mean that it doesn't exist. But that's what I'm trying to say. Like, it's like, I mean, yeah, no. That's being a little rebellious. I was gonna say, like, if you could break a rule, does that mean that shit really exists? Like, but no, that wouldn't have been a good analogy. The reality is that, okay, yeah, I hear what he's trying to say in that principle, like just because you could defy gravity doesn't mean it exists. But the reality is what I'm trying to tell you, the reason why it doesn't exist or it's being misnomered, what that reality of what that is actually density. Density is the reason why things are not pulled to the center of the earth. And that's another thing too, pulled to the center of the earth. Like literally being pulled down to the center. You know what the center of the earth is? Not the surface of the earth. You know what I'm saying? It didn't say, in the definition of gravity, it didn't say pulled to the surface of the earth. It didn't say that. It said the center of the earth. And now, the reason why they say that is because they say that lava in the earth or whatever, or some molten rock or whatever, and this is like, okay, we're going to go into it. You know what I'm saying? Hold up, wrong one. My bad, y'all. When they talk about like magnetism and stuff like that, because now people go into magnetism too. I've been hearing people talk about magnetism. Okay, now we're gonna break that down too. You know what I mean? Because my thing is like, okay, they say, because I looked up, like, humans, like, and they say are humans electromagnetic, and then they say the sun is electromagnetic. They say the earth is electromagnetic. You know what I mean? So now, but now magnetism we know is dealing with two opposite forces. You got a positive force and a negative force. You know what I mean? An attractive force and a repulsive force. So if both the sun and earth are electromagnetic, and that's dealing with electric and magnetism. Electric is having a positive and negative charge or a neutral charge. The magnetism is the attraction of the positive or negative. So first of all, they have to have either positive or negative to even be considered electronic or magnetic. But they say that both of them are electromagnetic. So that's like having two poles. So now we know that the sun doesn't necessarily have poles, quote unquote, to say. You know what I mean? But now they say about the earth, they say the earth has poles. These poles represent the positive and negative charge. Now, this is going, and then we will go into the magnetosphere, which is energy given off from the earth due to the positive and negative charge of the north and south pole. According to flat earthers, you know what I'm saying, they, like, you know, more specifically to Brother Sanchez, this is one thing that, like, listen, I agree with a lot of what he says, but this is one thing I'm kind of, you know, maybe if I ever get a chance to build a brother, maybe he could clarify. He speaks about magnetism, but the diagram, and he says that really there is no south pole. He said there's only the north pole. And now if that's the case, and he says, and he talks about magnetism, but if it's magnetism, you have to have a positive and a negative charge, or a positive and a negative pole, because when you only got one pole, that's dealing with what you call unipolar, and two poles is bipolar. So in order to have a magnetosphere, that has to be bipolar, and in order to have magnetism in general, there has to be a bipolar or a positive and negative charge. You know what I'm saying? Whether it's neutral or not, those two poles have to exist, or those two charges have to exist. So anyway, let's go into this right here, right? Okay, it says gravity. It says the force that attracts a body toward the center of the earth or toward having mass. So, like I said, so that means that all physical bodies that have mass, we should all be clinging to each other. Like you know how everybody's all packed up and clinging together. It should always be like that because of gravity, which is a force that, you know what I mean? Come on, man. That just doesn't make sense. It doesn't apply. So let's move on. You know what I mean? So y'all heard what gravity is, right? All right. Now we got okay. Then I asked Google, I said, does gravity have a positive or negative charge? It says, it answered, it does. The charge of gravity. Now listen to this, y'all. Do the knowledge. It says, the charge of gravity is mass. You heard that? The charge of gravity is mass. The charge of gravity is mass. Now, didn't I just say before about density? And density is basically the mass of an object, how much it weighs. You know what I'm saying? So now it just said the charge of gravity is mass. Now let's just skip over real fast for a second. Density. Y'all see this? It says density. The density of a substance is its mass per unit volume. You know what I mean? The most often symbol for density is P, but also the Latin letter D is also used. Mathematically, density is defined as mass divided by volume. Where P is the density, M is the mass, and V is the volume. So you got MP over V. Remember that equation in school? The mass or density over the volume, or divided by the volume. You know what I mean? So now it says mathematically density is defined as mass or volume. So now I just broke down to y'all about density, right? So y'all just seen what density was, right? And now it said and then mass, right? It said so density is the weight, right? And then it says the charge of gravity is mass. So see, this is the whole point of what I'm trying to say. That's why I say what they're calling gravity is actually density. So why don't they just say density? And we know that density is the weight of something. So I said the reason why people are held firm on the earth and the reason why we're not floating away is not because of a force called gravity. It's because of people's density. Because we have mass. We stay stuck on the earth. So we're solidified. And even though we have water, we have liquids and gases in us, but we're mainly composed in a physical or solidified form. So and we have mass. This is why we don't float away in the air. So elements like air, oxygen, helium, heat, things of that nature, those elements float away because they are to be like held here. Now, water. Now we know like it takes all types of things for things to happen, all types of stuff, cause and effect in the universe. So now when the sun shines on the water, like the lakes and the rivers and stuff like that, it causes what's called evaporation. You know what I mean? Like the Bill degree says, you know what I'm saying, this water is drawn up in a fine mist that the naked eye can hardly detect. You know what I mean? But as this mist becomes heavier and increases with other mists of water until it becomes, but as this mist increases, become heavier and but as this mist ascends higher and increases with other forms of other mists of water until it becomes heavier than gravity, until it becomes heavier. Damn, I'm messing up the Greek. Pardon me. Until when she becomes basically pardon me for messing up the degree. But then it distills back on the planet Earth in the form of drops of water, drops of ice, depending on how heavy, that's what I was trying to say, depending on how heavy the current was in the midst of air it was in. So now, that once again, how heavy the current was in the midst of air it was in. So when the sun shines on the water of the earth, it draws the water up and it causes what's called evaporation. It draws the water up in a fine mist, naked eye can hardly detect. But when the water becomes, when the current becomes too heavy, it distills back on the planet. It didn't say because of gravity it gets pulled down to the planet, because it gets heavy. It gets too massive. The cloud becomes too heavy. Then it starts to distill back to the planet. Now, now check it, right? My step pops had went through my lessons one time, like, you know what I'm saying, trying to go through my stuff or whatever. And anyway, the reason why I know he read through my stuff, because he tried to, and I gave him props. So he tried to sum up the Bill degree, because I was reading, trying to memorize, I was studying my lessons. I was trying to memorize the Bill degree, which is a mad long degree. I was trying to memorize the degree, what makes rain, hail, snow, earthquakes. You know what I'm saying? And da-da-da. So he must have read that degree or whatever. And when I woke up or whatever, he looked at me and was like, gravitation. And I was like, so I did the knowledge, like, oh, you trying to read my degrees and whatnot. He must have read the Bill degree and basically summed it up. And now, according to, what we've been taught, that gravity is supposed to be a force that pulls things down to the planet. In that sense, he would have been right. And that would have been actually very intelligent, the way he tried to basically sum up the Bill degree in one word. Gravity. You know what I'm saying? What makes rain, hail, snow, or earthquakes? Gravity. According to that definition, so-called, something that's supposed to pull things back to the earth or whatever. But it wouldn't be technically gravity. It would technically be density. So if you ask me what makes rain, hail, snow, or earthquakes, instead of me giving you a long old drawn out and quoting the whole degree, I'll simply tell you density. You know what I'm saying? Facts. Density. It's because of density. The weight. And it tells you right there in the degree that when the mist becomes heavier, you know what I'm saying, then the current of air was in, you know what I'm saying, then it distills back onto the planet in the form of drops of water or drops of ice, depending on how heavy the current was in the midst of air it was in. Now, it also says there are some layers very warm and some very warm and cold, and some very swift and changeable. So when the water strikes one of the cold currents, it becomes solid in small round drops and form, or in a light fluffy form called snow. So in other words, what causes snow is because not only is that when the water is drawn up and it becomes heavy, but also it becomes, being that it's in a cold current, when it comes back down, it's going to come down in a light, fluffy form called snow, or in a small round drops, what they call rain. But actually, when it's cold, that's what you call sleet. You know what I'm saying? You know how you get them little pellets coming down? That's called sleet. You know what I'm saying? So technically, when you break down that Bell degree, you got rain, hail, snow, and earthquakes, and you also got sleet in there too. Because those small round drops can be rain, it can also be sleet. You know what I'm saying? So anyway, you know, let me not drift too far into that though. But it's all relevant. This is like Earth Science 101. This is I love this, man. Science is I love science, man. Science is what it is. So anyway, so I asked, does gravity have a positive charge? Let me see how far I am on this right now. Okay, 34 minutes. All right, this gonna be an hour-long show, maybe a little longer, but anyway, it's all worth it, y'all. So let's get it. So basically, I already defied gravity, and I already showed you that gravity really doesn't exist, and what it really is density. I already proven that point. So really, I could end this video right here, but I want to go on and show y'all some more science. You know what I'm saying? Matter of fact, since I know the people that I'm gonna send this to probably ain't gonna listen so long, listen, I already broke it down right now. I already showed y'all that gravity doesn't exist. What gravity really is really density. You know what I'm saying? I broke that down. You've seen the definition of density. You know what I mean? It's the weight of something. And coming back on the next show, I'm gonna get into repulsion. I'm gonna do a part 2, and we're gonna deal with repulsion, because actually the name of this is called gravity or repulsion. And which one is it? So we're gonna go into repulsion in the part 2 of this. All right, y'all. So on that note, y'all, I'm gonna say peace, and I'm gonna see y'all in the next session. All right. Peace.